So 9-2 is the same idea as 9-1, but now we're just dealing with our sample standard deviation. So it's going to have the same sort of process and the same sort of formula. We just have to adjust for a sample standard deviation. So the formula for this one should be T equals, remember when we're working with a sample standard deviation, we do not use z-scores, we use t-scores. So it's going to say T equals the same numerator as before, divided by technically the same denominator, but just different variables to show that we have a sample standard deviation, plus s sub 2 squared over n squared. So everything's pretty much the same. Again, the only difference is this piece right here. So everything I said in the first video is going to be applicable to this. It's just we have to know that that S stands for the sample standard deviation, right? And it's either going to have an S that we can sort of read, or it's going to say sample standard deviation. So those are the key words we're looking for. And then, of course, our confidence intervals are the same sort of idea, but now we're just dealing with our T. So it'd be x bar sub 1 minus x bar sub 2, all of that, plus or minus T sub alpha divided by 2 times the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. All right, so again, same exact thing as before, just dealing with the s variable now instead of the sigma or the O value. So let's do a quick example. Here we have this sort of the same process again. It's the same setup, and we're going to see if it's going to be a population standard deviation or a sample standard deviation. So a study was done to see if there was a difference between the number of sick days men take and the number of sick days that women take. A random sample of 9 men found that the mean of this of the number of sick days taken was 5.5, and the standard deviation of the sample, okay, so that phrase right there, of the sample, that tells me we're going to be using a t-score. So we have to adjust our formula just a little bit. It's the same thing, but we're just going to adjust it a little bit so that we can have that. And then I'm going to change the color for my females. A random sample of 7 women found that the mean was 4.3 days with a standard deviation of 1.19 days. And then we can go back to our just sort of general information. Alpha equals 0.05. Can it be concluded that there is a difference? Okay, remember difference is our does not equal to in the means. So I have all my pieces. I have n, and I'm gonna put n1 because it's my first sample size. Here's my first mean. Here is my first standard deviation. All right, so that's all labeled, and then this is going to be my second sample, and my second average, and my second standard deviation. So now that I have all that, I can go ahead and begin. First things first, let's write our hypotheses. The first one is always going to be when they are equivalent to each other. All right, and then from the last sentence we saw, I put does not equal. For our alternative, it's going to be when it does not equal, because that is what we had down here at the bottom. The word difference is what tips us off for that. We can find our critical values from our alpha. Alpha is, again, 0.05. We have to divide that by 2, and it should give us 0.025. It's the same thing as we did before. So again, if we go to our table with our scores, then we should get a different answer only because we're using a different table. Okay, so in the previous one we used a z-table, and if we were using the z-table again, well then there would be no issue, but because we're not using a z-table this time, we're using a t-table, we actually need to use a different thing. So we're going to go to our teams. Here we are right here. We're going to click at the very top where it says Files, right here at the top. I'm going to go and click on my T-scores, which is going to be right here. And here is the PDF as it pops up. And I can sort of make this a little bit bigger. I'm going to zoom in just a little bit, maybe 125, just to make my life a little bit easier. It is a two-tail, and it is when alpha equals 0.05. So that's going to be this column right here, because it is a two-tail. Alpha is 0.05. There it is. All right. So off to the side, we see our degrees of freedom. Remember, degrees of freedom is going to be our sample size minus 1. And because our sample sizes are different, we are going to pick only one of them, and it's always going to be the smaller sample size. So if you remember, our problem gave 9 men and 7 women. So 7 is our smaller sample size, so that's what we're going to use for our degrees of freedom. And 7 minus 1, because remember, to find the degrees of freedom, you take your sample and subtract 1, so it would be 6. All right, so here we have our degrees of freedom is 6, and we just go across, sort of bouncing across over here, and we see that our critical value should be 2.447. All right, now remember, because it's a two-tail, it's going to be positive or negative 2.447. So let's go back to our other screen. All right, so our critical value from our t-table this time, because remember, the t-table, because we used a sample standard deviation, is going to be positive or negative 2.447. So I can draw my picture really fast. That was a terrible picture, terrible curve. There we go, it's a little bit better. And it's even farther out this time. We got a positive 2.447 and a negative 2.447. Now that I have my critical values, I can draw where my critical regions are going to be, which is anything farther than that middle piece, which is 0, obviously. Okay, so now that we have that, we can plug into our formula. T is going to be equal to the difference of our averages, which is 5.5 minus 4.3. All of that over the square root of our standard deviation. Remember, standard deviation needs to be squared, so it's going to say 1.23 squared over, and the men had 9 in their sample, and then 1.19 squared, because that's our second standard deviation, over 7, because that's how many women we had in our sample size. All right, time to go to our calculator and see what this all equals. So I just went ahead and set up my fraction, and now I'm going to type in everything. 5.5 minus 4.3, all of that over 1.23 squared over 9 plus 1.19 squared over 7. And let me just make sure I've got all my numbers correct. And I do, so I'm going to go ahead and press enter, and I get a test value of positive, and I'm going to go to 3 decimal places because that's where my critical value is, 1.972. So I'm going to go to my other screen and write that down. 1.972. All right, so I'm going to change my color and put that in here and see where it is. I got 0 over here. Positive 1.972 is off to the right-hand side, and I just got to ask myself, is it less than or greater than 2.447, that critical value? And it's less than, so it's going to be on the left-hand side, and we'll say it's about here-ish, and we'll say 1.972. So we can see that this time it is not in our shaded area, or not in our critical region, so we would say we do not reject. We do not reject. So if we were creating our picture, or creating our box to figure out which statement we're going to pick, we can cross out our null hypothesis because our claim was our alternative, and we are not rejecting, so it'll be this bottom piece here. And so our summary will be, there is not enough evidence. There's not enough evidence to support this claim. All right, and then that is our answer. Our next one is asking us to find our confidence intervals for the exact same problem we just did. So we have all of our pieces. Let's go ahead and just write down the pieces that we had, or the pieces that we need. We need our averages. That's 5.5 and 4.3. We need our t sub alpha divided by 2, which we already did. That's our critical value. It's positive or negative 2.447. That is the population one. Our sample standard deviation was 1.23. Our second one was 1.19. Our first sample size was 9 men, and our second sample size was 7 women. So now that we have all these pieces, we can plug it into our formula. That should read as 5.5 minus 4.3 plus or minus 2.447 times the square root of 1.23 squared over 9 plus 1.19 squared over 7. Plug this all into our calculator and see what we get. So let's go off to our calculator now. Okay, use parentheses for that first little bit. 5.5 minus 4.3. And we'll do our subtraction first. Minus 2.447 times the square root. And let's get our fractions there. Oops, not there. Plus, and then our second fraction. Okay. 1.23 squared over 9. And then 1.19 squared over 7. Press equals, and our first one is negative 0.289. We do this second and then entry to get this back, and keep pressing the right arrow until we can get to our minus sign and change it to a plus sign, and it changes that to 2.689. 2.689. All right, now that we have that, we can go and continue writing this down. All right, so we had negative 0.289 and then 2.689. And remember, when I did this in the first video, I said that if it contains 0, then we do not reject. But if it does contain 0, or if it does not contain 0, we would reject our claim. And in this particular case, it does contain 0. So it contains 0. Therefore, we do not reject. We don't reject, which makes sense because in our other example, or in our, not our other example, but the one we just did when we were doing it the normal way, we did not reject it because our number 1.972, that test value, was not in the shaded region. And since it was not in the shaded region, we could not reject it. And so it makes sense that when we do our confidence intervals, it does contain 0, so we cannot reject. So we're coming to the same conclusions, we're just taking 2 different routes. I know we didn't practice this a lot during class time, but it's the same thing, and we've done confidence intervals before, back in like chapter 7 or something, so it shouldn't be anything too terribly new. And as you've noticed in the homework, we're not really reviewing over the confidence intervals. I'm really testing you over the steps that I need you to know, which is more like our first example where we go through all of our process, name our hypotheses, all that fun stuff. But this is just to further show that we could, if we wanted to, just focus on the confidence intervals and still come to the same conclusion. So hope that is helpful, and make sure you do your forms online, and make sure you ask me any questions either on Remind or with email or on Teams. Teams is pretty good. It's pretty fast. So just let me know if you need anything.